Okay, now this is from the MCR class, and it says pretty much what we did before. We're going to point it out in case you need to look at the video. Got a vertex at -7,3, a point -12,10. We want to find the standard form of the quadratic. So we write down the standard form of the quadratic. Actually y equals a times x minus h squared plus k. Horizontal shift is the h, vertical shift is the k, vertical stretch is the a, for all the reasons we went over last time when we started with the y equals x squared function and vertically stretched it, then horizontally shifted, and vertically shifted it. So remember what we did last time fits into this scheme here. So standard form then, okay, we know the vertex, so we know h and k. So we plug in h and k. H is -7, k is 3. We get y equals a times x minus -7 squared plus 3. I don't have to read it to you, it gives you this. We expand this. Well, no, we don't yet expand this. We have to solve for a. We don't know a, and then we're going to expand it, okay? We determine a by taking the coordinates of the known point, plugging them in. So known point x is -12, y is 10. Plug that in for x and y, we get this equation which we solve. We get a equals 7/25. I don't guarantee I did that right. I kind of think I did. So fix it if it's wrong, but that's what you do and how you do it, okay? So now our standard form is this. Just replace the a with the value that we just got for a. Expand it, distribute, you get this. There's your general form, okay? Then, if you want, you could substitute. Well, how do you find the vertex given the general form? Well, vertex is on the axis of symmetry. That's at -b over 2a. Remember how that fits into the quadratic formula, and make sure you do know the quadratic formula. So let's see, -b over 2a for this would be negative of this over double this. That'd give you 98 over 7. And 98 over 7 is, no, I'm sorry, 98 over 14, okay? That's 7, okay? And so it should be negative b over 2a, negative this over this, and that does give you -7, so I suspect that I at least got that part of the vertex right, okay? Understand what I just did? If I was just given this, I could find the vertex, and it would be on x equals -7. And then we could plug -7 in for this. That'd be a little bit of a pain, so I'm not going to do it. Okay? But we should get 3. Okay, well, now, first problem on the sheet that you have in your hand, I'm not going to do because it's the same thing we did last time, but if there's your function, what's the standard form? 2 ways to get the standard form. One way is complete the square. We're going to talk about that. Maybe today, but maybe not till Tuesday. Depends what we get done today. Another way to get the standard form, though, is to realize that the number in front of x squared is the same as the a that you have in the standard form. Because if you expand this, you're going to get an ax squared, right? And that's your vertical stretch, and of course you need to know that. Okay? So we know that a is going to be 2, right? So we know what number to put in here. We don't have to have another point or anything to determine what a is. We know that a is 2. The axis of symmetry is at x equals -b over 2a. b is 3. So we plug in and we find that the axis of symmetry is at x equals -3/4. So we kind of sketch that on a graph. Here's our y-axis, our x-axis. Here's the line x equals -3/4. Our vertex has to be on the axis of symmetry because that's the axis that cuts the parabola in half. Okay? And again, the graph of a quadratic function is a parabola. So all we have to do to find the standard form, we've already determined h, right? That's the x-coordinate of the vertex. We've got an h to put in here, we've got an a. So it's going to be 2 times x minus negative 3/4 squared, right? Okay? So all we need to do is find k. Well, k is the y-coordinate of the vertex. How do you find the y-coordinate of the vertex? If you know the axis of symmetry, you plug that x-coordinate into the function and it gives you the y. So we plug that in and we get this. Okay? So now we can write the standard form. The vertex is negative 3/4, 191 over 8. That's 191 over 8 is what we get when we plug in negative 3/4 for the function. Vertical stretch factor is 2, because that's a coefficient of x squared. So the standard form is y equals 2 times x plus 3/4 squared plus 191 over 8. It's plus 3/4 because it's minus h, right? You got to be careful about that. Okay, so that's a quick summary. Want to see that done in more detail? The video's will be up there.